Welcome to the deep dive. Today, we're taking a close look at the world of React.js.
Yep.
But not just the theory, right? We're diving into those, scenario-based questions.
Was it really test your actual problem-solving skill, not just reciting docs?
Exactly. So the mission today is to sharpen your edge for that next front-end interview.
That's right. We'll unpack some practical solutions to common, sometimes tricky React challenges. Think of it as getting you ready for the real-world stuff.
Okay, let's jump right in then. First scenario. Imagine you're building something in React, and you have a component, right? It needs to render a huge list, like 1,000 items, maybe more.
Mm-hmm.
And users are reporting lag. It feels choppy. What's the first thing you think of? Where's that bottleneck?
Yeah, that's super common. The big mistake is trying to render all 1,000 items directly into the DOM, even if, only 10 are visible on screen.
Right, the browser just can't handle that many elements efficiently.
Exactly. So the primary solution, the go-to, is implementing something called windowing or virtualization.
Windowing. Virtualization.
Yeah, basically the same concept. You use libraries like React Window or React Virtualize. They're really clever.
How do they work?
Well, they only render the items that are actually inside the user's current viewport. So maybe only 10 or 20 items are actually in the DOM at any given time, even though the list feels like 1,000 items long.
Okay, so it's like an illusion, but a very performant one.
Precisely. It dramatically cuts down the browser's workload.
So windowing is key. But are there other steps, other things to check for performance with lists?
Absolutely. Beyond just windowing, you have to be careful about unnecessary component re-renders. This is a big one in React generally.
Okay, how do we tackle that?
React gives us tools. React.memo is your first stop. It memoizes your component.
Memoizes meaning it caches it.
Sort of, yeah.
Yeah.
It caches the rendered output. If the component's drops haven't changed, React just skips re-rendering it altogether. Saves a lot of work.
But there's a catch, right? I remember something about how it checks props.
You got it. React.memo does a shallow comparison. So if you pass down an object or an array, even if the data inside it hasn't changed, the reference itself might be new on each render.
Ah, the reference equality problem. So React.memo might think things change when they really didn't, content-wise.
Exactly. So for those cases, you might need useMemo to memoize specific complex procs, like a derived object or array, or use callback for functions.
We'll probably circle back to use callback.
Definitely. And one more thing for big apps. Don't forget lazy loading and code splitting. Reduce that initial bundle size. Makes the app feel faster right away.
Good point. Understanding all that really improves the user experience, especially with data-heavy apps.
Totally. Makes things feel snappy.
Okay, moving on. Let's talk about something else I bet a lot of us have hit. You've got a component, it fetches data in useEffect when it mounts. Standard stuff.
Yep.
But sometimes if the user clicks away, navigates somewhere else while that fetch is still happening, you get that warning in the console.
Can't perform a React state update on an unmounted component warning. Yeah. It's annoying and potentially a memory leak.
Right. How do you handle that gracefully?
This really highlights why cleanup is so important.
Yeah.
The best way now is using the browser's built-in abort controller.
Abort controller. Okay, how does that work?
So before you make your fetch request, you create an abort controller instance. You get its signal property.
A signal.
Yeah, it's like an object you pass into the fetch options.
Mm-hmm.
Then the crucial part is inside your useEffect, you return a cleanup function.
The function that runs when the component unmounts.
Exactly. And inside that cleanup function, you call controller.abort.
So it's like you're attaching a little kill switch to the fetch request.
That's a great way to put it. When abort gets called, the signal tells the ongoing fetch, hey, stop what you're doing. The promise rejects with a specific abort error, which you can catch, but crucially, it won't try to call setState anymore.
Because the component is gone.
Right. So no memory leaks, no console warnings. It's just clean. It's really a must-know pattern for stable React apps.
That makes perfect sense. Essential for robustness. Okay, shifting gears again. What if you need to share state across many components, like user login status, maybe themes settings, stuff that needs to be available way down the component tree, but you're not using Redux or ZooStand or something like that? How do you avoid, prop drilling hell?
Yeah, passing props down 5 levels deep is painful. This is the classic use case for React's built-in context API.
Right.
The pattern's pretty straightforward. You create a context object, say user context. Then somewhere high up in your componentry, maybe around your whole app, you wrap everything in user context.provider.
And that provider holds the value like the logged-in user object.
Exactly. It takes a value prop, and that value becomes available to all components nested inside it, no matter how deep they are.
Okay, so the provider makes it available. How does a component way down the tree actually get that value?
That's where the use context hook comes in. Inside any functional component that's a descendant of the provider, you just call it use context, user context.
And it just gives you the value.
Yep, it returns whatever value was passed to the nearest provider above it. It's super clean.
That's much better than prop drilling.
Oh, way better. And you can even combine it with custom hooks. Like you could create a use-auth hook that uses user context internally, but also bundles maybe the login, logout functions. Keeps things really organized.
Nice. Any downsides to context?
Well, the main thing to be aware of is that when the context value changes, every component consuming that context will re-render.
Ah, so maybe not for state that changes, like super frequently.
Exactly. For things like user authentication status or theme, which are fairly stable, it's perfect. For high-frequency updates, you might still reach for something more optimized later, but context covers a huge range of use cases really well.
Good to know. Okay, let's talk forms. Always fun.
Yeah.
What if you're building a complex form where fields dynamically show up or hide based on what the user selects? You know, like choosing a country shows the state's field.
Conditional logic.
And you need to handle validation properly in that dynamic scenario. That sounds like it could get messy fast.
It totally can if you try to manage it all manually with useState. This is where I strongly recommend using a dedicated form library.
Like which ones?
My go-to these days is React Hook Form. It's designed for performance, it minimizes re-renders, and it makes handling dynamic fields and validation much, much easier.
Okay, so with React Hook Form, how do you do that conditional showing, hiding, and validation?
It has a really neat function called watch. You can use it to subscribe to changes in a specific input's value.
So you watch the country field, for example.
Exactly. Const selected country, watch country. Then in your JSX, you can just conditionally render the states field. Selected country, USA, and states field.
Okay, that handles the rendering. What about validation, like making the state field required only if USA is selected?
You can put that logic right into the register function for the conditional field. The validation rules object can itself depend on watched values. So you might say register state required, watch country USA. State is required, med values.
Ah, so the rules themselves become dynamic based on other inputs.
Precisely. React Hook Form handles tracking all those dependencies and applying the rules correctly. It simplifies what can otherwise be a real headache.
Definitely sounds like the way to go for complex forms. Okay, let's loop back to performance again because it's just so crucial.
Always.
Let's say your app is growing and you notice using the dev tools that lots of components are re-rendering way too often, even when their props seem the same. How do you tackle that kind of widespread re-rendering?
Yeah, this is where understanding React's rendering behavior and the tools we mentioned earlier really pays off. First, revisit react.memo. Are your components wrapped in it where appropriate?
Checking that components only re-render if props actually change.
Right, based on that shallow comparison. Then, look for expensive calculations happening directly inside your component body. Are you doing heavy data processing on every render?
Stuff that could be memoized.
Exactly. That's the job for useMemo.
Yeah.
Wrap the expensive calculation in useMemo, provide its dependencies, and React will only rerun it if those dependencies change. It caches the result otherwise.
Okay, so React.memo for components, useMemo for calculated values. What about functions passed as props? We touched on this.
Yes. This is a super common cause of unnecessary re-renders, especially with React.memo. If you define a function inside your component body, like const handleClick, through Agitboard, that function gets recreated on every single render.
So even if the child component is memoized, it sees a new handleClick prop each time.
Bingo. And it re-renders unnecessarily. That's precisely what useCallback is for. You wrap your function definition in useCallback, provide its dependencies.
And useCallback gives you back a memoized version of the function.
Right. The function reference only changes if one of its dependencies changes. So now, your memoized child component gets the same function reference most of the time and avoids re-rendering.
So memo, useCallback are the core optimization toolkit.
They are. And critically, how do you find these problems? You absolutely need to use the React DevTools profiler.
Right, the profiler.
It lets you record interactions, see which components re-rendered, why they re-rendered, props changed, state changed, context changed, and how long they took. It's indispensable for diagnosing performance issues.
Mastering those techniques is key for scaling React apps.
Absolutely crucial for responsive UIs.
Okay, but what if the network is the bottleneck? You've optimized your React code, but users on slow connections are still waiting, say, 4, 5, 6 seconds for API calls to finish.
Yeah, that's a tough one because you can't magically speed up their network.
So what can you do? It's about user experience at that point, right? Managing the wait.
Exactly. It's all about perceived performance and managing expectations. The instant an API call starts, you need to show immediate feedback. Don't leave them staring at a blank space or an unchanged screen.
Like putting up a spinner.
Spinners are okay, but even better are skeleton loaders. Those gray boxes that mimic the shape of the content that's about to load.
Ah, yeah. They make it feel like things are happening, preparing the space. Reduces that blank screen anxiety.
Totally. It gives a sense of progress. Another thing, while data is loading, disable relevant form elements or buttons
Why is that?
to prevent the user from, say, clicking submit twice because they thought the first click didn't work, or changing options mid-request, which might lead to weird states.
Yeah.
Avoids user frustration and errors.
Makes sense. Any other strategies?
You could explore prefetching data. If you can reasonably guess what data the user might need next based on their actions, fetch it ahead of time in the background.
So it's already there when they navigate.
Ideally, yeah.
Yeah.
And, where it makes sense and is safe, consider optimistic updates. You update the UI immediately, assuming the API call will succeed. For example, if a user likes a post, you show the like state instantly, before the server confirms it.
Oh, okay. So it feels instantaneous.
Right. But you must have solid logic to handle the case where the server request actually fails later, so you can revert the UI change and maybe show an error message. It's not suitable for everything, but great for perceived speed when applicable.
So loaders, disabled states, maybe prefetching, optimistic updates, and good communication.
Yes, clear messages letting the user know what's happening, loading your data, saving changes
Yeah.
are vital. It's about making the wait less painful and more transparent.
Got it. Let's switch to the business side a bit. SEO, search engine optimization.
Ah, yes, the classic SPA challenge.
Your marketing team comes to you. They want the React app, this single-page application, to rank better on Google. SPAs often struggle because crawlers might just see an empty HTML shell initially. What's the main fix?
The gold standard solution here is server-side rendering, or SSR.
Rendering on the server.
Right. Frameworks like Next.js are built around this idea. With SSR, when a user or a search crawler requests a page, the server runs the React code, generates the full HTML for that page, and sends that down.
So the crawler gets a complete HTML document immediately, with all the content.
Exactly. It sees the text, the links, everything. It doesn't need to execute JavaScript to see the content, which makes it perfectly crawlable and indexable by search engines.
That makes total sense. Next.js is a popular choice for that. But what if using a framework like Next.js isn't an option, maybe due to existing infrastructure or complexity? Are there alternatives?
There are, though, generally less effective than full SSR for SEO. One key thing is managing your metadata properly. Libraries like React Helmet let you dynamically change the title tag, meta descriptions, and other head elements for each page or view in your SPA.
So at least the title and description in search results are right.
Correct. That's important. Another approach is pre-rendering. You can use tools, maybe like Puppeteer or specific build plugins, to essentially visit key pages of your app during the build process and save the resulting HTML as static files.
So you generate static HTML for your main pages beforehand.
Yeah. The crawler hits those static files. It's good for landing pages or core content. Doesn't work as well for highly dynamic user-specific content, but it's an option. It really shows how technical choices directly impact business goals like marketing and reach.
Definitely a connection developers need to be aware of. Okay, last scenario. Let's talk code quality, maintainability, developer efficiency.
Super important as apps grow.
Imagine you built a really nice button component. It's used everywhere, maybe 20 different places in the app.
Uh-huh.
Then the design team comes along with a change. Maybe they want a new secondary button style or different sizes. Now you need every instance of that button to support this new variant. How do you handle that efficiently?
This is the perfect example of why investing time in truly reusable components pays off massively. The approach isn't to go update 20 places. It's to make sure your original button component was designed for this.
How so?
By making it flexible through props. Instead of hard-coding styles, the button should accept props like variant, size, maybe icon, is disabled, and definitely on click.
So you'd have like button variant, secondary size large button?
Precisely. The component's internal logic uses those props to apply the correct styles and behavior. So when the new design comes, You update the central button component to understand the new variant secondary, or the new size small.
And because all 20 instances were already using the props-based approach.
They automatically get the new styles of behaviors without you needing to touch those 20 locations.
Mm.
It ensures consistency and makes updates way faster and less error-prone.
That's huge for maintainability. But how do you make sure other developers on the team know how to use this flexible button correctly, with all its variants and props?
Great question. Documentation is key, but even better is using a tool like Storybook.
Storybook.
Yeah, it lets you develop and document your UI components in isolation. You create stories for your button, showing exactly how it looks and behaves with different combinations of props, variant primary, variant secondary, size, small, disabled, etc.
So it's like a living style guide or component library for your project.
Exactly. Developers can go there, see all the options, copy usage examples, and even test edge cases without needing to run the full application. It drastically improves discoverability and correct usage of reusable components.
Investing in that reusability and documentation really pays off long term.
Massive dividends in maintainability, scalability, and just developer sanity. Foundational stuff.
Wow, okay. And that brings us pretty much to the end of our deep dive for today. We've covered a lot of ground in React.js performance with large lists, handling those tricky API cancellations, managing global state with context, dynamic forms, fighting re-renders, dealing with slow networks, SEO strategies, and building reusable components.
Quite a tour through common React challenges.
It really underscores the idea, doesn't it, that true skill in React, or really any development, isn't just knowing the syntax. It's about applying that knowledge to solve these kinds of real-world problems effectively.
Absolutely. It's the practical application, the how and why, not just the what.
So maybe a final thought for you, the listener, to chew on as you continue learning. How does understanding these common problems and seeing the patterns in their solutions change how you might approach learning a new framework or technology next time?
That's interesting. Does knowing the pitfalls help you learn faster?
Right. Is it more effective to learn by just building features? Or by actively looking for and understanding how to troubleshoot common issues? What problem, what challenge are you curious about solving next? Keep building, keep learning.